Okay, so we're into the second 40 marks of the WJEC Intermediate Paper 2 from the or Maths Intermediate Paper 2 from the summer of 2018, and we're kicking off with some calculated arithmetic. So for this first one, what you want to try and do is to put that into your calculator in exactly the same way you see it. So we're going to use a fraction key to create the fraction. On the top, 145.3, and underneath, open bracket, 12.4, take 9.8, close bracket, and then that's cubed to the power of 3, and we've got a button for that as well. So that's looking exactly the same as that. So there's my answer. Now I'm going to write that down as it stands, because that's going to get me a mark even if I mess up the significant figures. So 8.26695493 mark. So for the second mark I need that 3 significant figures. So the 3 significant figures are the ones that hold the most place value. So that one is a units, so that holds the most, then the tenth, then the hundredths. So my answer to 3 significant figures is either going to be 8.26 or 8.27. And you look at the next digit along as you would with decimal places. It's 5 or more, so that means that that is closer to 0.27. So first significant figure, second, third. Or we would write 3 SF after it, like that. Reciprocal is a word, it's a trigger word in maths. What it means is 1 over, and you need to know that. So the reciprocal of 47 means 1 over 47, or you can write it as 47 to the power of -1. Either of those, when you put in your calculator, will give you the right answer, as I'll show you now. So 1 over 47 will give you that, which you would also get if you did 47, and you can see there -1 button. Same thing. So either of those, and again, to get that first mark, I'm going to write down that's my calculator display, and that's 1 mark. To get the second mark, I want 4 decimal places. This is the first decimal place, the first digit after the decimal point, second, third, fourth. So it's either going to be 0.0212 or 213. Next one over is 5 or more, so it's closer to 0.0213 to 4 dp. So the important thing is to actually put that line in where you're writing down what your calculator is showing you, because even then, if you mess up the significant figures or decimal places, you're definitely going to get 1 mark for doing the maths part of it correctly. Question 12. Which of the following values cannot be an external angle of a regular polygon? Well, if we just flick back to an earlier question where we were looking at external angles of a regular polygon, and what we determined, or what you needed to remember, was that they add up to 360. And we use that to work out what each one of those would be by dividing by the number of sides. Or alternatively, if you divide 360 by the external angle, it will tell you what the number of sides are. So if we do 360 divided by that angle, and it gives us a whole number, then it will be an external angle on a regular polygon. It'll tell you how many sides that polygon would have. So when I do 360 divided by 10, I get a whole number. so that one's okay. If I do 360 divided by 18, I get 20. So that one's okay, it's a 20-sided polygon. If I divide by 30, I get 12. That's a 12-sided polygon. If I do 360 divided by 48, I get a fraction. I can't have a 7.5-sided polygon, so that one isn't. And if I do 360 divided by 72, I get 5. So that's a pentagon. So which of the following values cannot be an external angle? 48 degrees. An arrow on a spinner is facing north. It is turned clockwise through an angle of 1530 degrees. In which direction will the arrow now be facing? So each time it spins through an entire rotation of a compass, it's travelled through 360 degrees. So if I do 1530 divided by 360, the whole number part will be how many complete spins from north back to north there will be. Four and a quarter. So that means 4 complete spins, and then on the final spin it's going through another quarter of a turn, which takes it to east. Point A is on a bearing of 100 degrees from point B. So we're measuring from point B. And 100 degrees is going to be like that. So point A is down there somewhere. That's north 2. So the bearing of B from A, I need that angle. Now north-south are parallel, so with parallel lines, that angle is the same as this angle here. So that I know is 100 degrees. That's your Z angle. So if that's 100, so is that. What a messy blob I've made of that. And the bearing is measured from north clockwise. So it's going to be 180 there, north to south, plus 100 to get back to that is 280. So that's the back bearing, as we call it. Question 13, a nice trial and improvement. If you can use your calculator, this is usually 4 easy marks. So we know it lies between 4 and 5, and we want our answer correct at 1 decimal place. So we go halfway to start. And when I teach this, what I say to students is, if you imagine that that X, when I want to replace it with a number, I burst it open, and when it falls back down, the 2 parts of the X actually fall as brackets. So when I break it open to put a number in it, it becomes a bracket. So the X cubed becomes 4.5 cubed minus 7. I'm going to burst the X to replace it with 4.5 minus 51. Once we've learned to write it like that, that's exactly how we write it into the calculator. So open bracket, 4.5 cubed. Remember, we've got a cube button, minus 7, open bracket, 4.5, take 51. I'm looking for a value of 0. That 4.5 is giving me a value of 8.625, which is bigger than it. So choosing that gives me a value that's too big. So now I know I'm searching for a number between the lower value 4 and 4.5. There's no point going to 4.7, because if that's too big, 4.7 certainly will. So that's the improvement part of it. So I'll go 4.3. burst the x, and see what that gives us. Open bracket, 4.3, close bracket, cubed, minus 7, open bracket, 4.3, minus 51 equals. So we got a negative value there of minus 1.593. I'm looking for 0, that's negative, it's too small. So there's no point going to 4.2, but it could be a value between 4.3 and 4.5. Before I start working to one decimal place, before I stop, I need to get these numbers consecutive. They're not consecutive at the moment because there's a 4.4 between it. So I now need to go to 4.4. So it's 4.4 cubed minus 7, 4.4 minus 51. Open bracket, oops, cubed minus 7 lots of 4.4 minus 51 is positive. Too big. So I know that my value of x is between 4.3 and 4.4. So to one decimal place, my answer is either going to be 4.3 or 4.4. I now have to decide which one. And in order to do that, I have to go halfway between again. So to decide which, we go x equals, so halfway between 4.3 and 4.4. If you're not sure, think what would halfway between £4.30 and £4.40 be? £4.35. You give me without thinking. So 4.35 cubed minus 7 lots of 4.35 minus 51. Which is too big, it's positive. Now to try and explain how that helps. What we've done here now is we know that my answer is either that or that. And I've gone halfway. Now because 4.35 is too big, that means everything between 4.35 and 4.4 is too big as well. So my answer is between 4.3 and 4.35. Now whatever value lies between 4.3 and 4.35, when you round it to one decimal place, is going to be 4.3. So because that's too big, my answer is the smaller value. If that had been negative, too small, then that would have knocked out all of those, and any value that side rounds up to one decimal place to 4.4. So to get those 2 marks, 1 mark would be for any correct plugging in. 2 marks would get you, you're doing 2 marks if you got down to saying it's between 4.3 and 4.4. But to get the extra 2 marks, you have to do that extra step to decide which one of them it's going to be. It's a really straightforward method to learn and is always worth 4 marks, or sometimes more. Question 14. The highest common factor of 30 and 75 is the square root of a number. What is the number? Well, let's find out what that highest common factor is first of all. Easiest to work with factor pairs. Factors are numbers that divide exactly into that one. So let's be systematic about this. If 1 divides into that, the other factor is 30. 1 times 30 is 30. 2 divides into it 15 times. 3, 10 times. 4 doesn't divide into it. 5 goes into it 6 times. 6 goes into it 5 times. So we've got them all there because the next one is just a repeated pair. We are now going to list the common factors of 75. And what I'm looking for is the highest number that's in both lists. So I don't have to list all of the factors of 75. I'm looking for the first number that's going to appear in this larger list that is also in that larger list. So 1 goes in 75 times, 2 doesn't because it's odd. 3, if you're not sure, remember we're on a calculator allowed paper, so don't faff about with a non-calculator method that you might make a mistake on. 25 is 25 in the list? No. 4 won't go into 75 because it's even. 5 goes into 75. Oops. 15 times. 15 is in the list, so I can stop. The highest common factor is 15. Now let's try and make sense of the second part. This is the square root of a number. So this is saying if you take a square root of a number, you will get 15. 15 is the square root of something, is what it's saying. So in order to work out the something, I'm going to do the opposite of square rooting, which is squaring. 15 squared, 225. So 1 mark you would get for finding the right highest common factor. The second mark is for then working out that if you've got 225 and you take the square root of it, that's what you get. The cube root of that is 33⅓% of a number. Okay, well let's deal with the cube root bit first of all. Cube root looks like this. On your calculator, you've got a cube root button. It's above the square root button. So we do shift, square root, cube root, and then type in 32.768. 3.2. Now a common equivalence that you should know is that 33⅓% is the same as 1/3 as a fraction is, or as a decimal it would be 0.3 recurring. So this is saying 32.768, the cube root, sorry, 3.2 is 1/3 of a number. So to work out what the number is, I've got to find 3/3, so I have to multiply that by 2. Sorry, by 3. So the question mark is 3.2 times 3, which is 9.6. Sorry, that's gone off the... So that's 9.6. So again, there'd be 1 mark there for using your calculator correctly to find the cube root, and then the second mark for undoing what they're telling you. So it's the language of the maths that's quite tricky with that one. Right angle triangles. PQR is a right angle triangle as shown below. PQ is 1.41, PR 0.89. Calculate the length of QR. We don't know any angles, we aren't being asked to find any angles, so it's not trig. This is Pythag. You're given a right angle triangle, you know 2 sides, you want to find the third. How do you do it? Well, first of all, you square the numbers that you're given. So 0.89 squared, 0.7921, 1.41 squared, 1.9881. Once you've done the squaring, you then have to decide whether you're going to add them or subtract them. That depends on the side you're trying to find. If the side you're trying to find is the hypotenuse, pointed to by the arrow, that's the hypotenuse. The hypotenuse is longer than the other two sides. So in order to work that out, I need a number that's bigger than these two. So I'm going to add them together. If they give you the hypotenuse, then you're trying to find a shorter side, so you need to make these numbers smaller by subtracting. So RQ is going to be, and I'll come back to why I've just written that there, 0.7921 plus 1.9881. I'm working with squares. I've squared that, I've squared that. That means that's going to become a square, which is why I've written RQ squared. So back to the calculator, 1.9881 plus 0.7921, 2.7802. So that side now I know has a square of 2.7802. So to bring it back to the ordinary length, I've got to do the opposite of squaring. Which is that, square rooting, square root my answer, 1.6673, etc., etc., etc. It's not asking you to give it to any degree of accuracy, so it's your call. My suggestion is you would use the same degree of accuracy that they're given. So if they're given to 2 decimal places, you give your answer to 2 decimal places. However, it doesn't matter. It's not asking you to give it to a degree of accuracy, so writing down your calculator screen would have been fine. That should be a bit bigger than those two, and it is. I'm happy. Question 16, probability tree. Visitors to the top of Snowdon can either walk up the mountain or take the mountain railway from Llanberis. On a particular day, a visitor to the top of Snowdon is chosen at random. The probability that this person is female is 0.42. The probability that this person took the train is 0.35. The decision to walk or take the train is independent of gender. So that means it doesn't depend on girls. The probability of train or walk is different for girls than it is for boys. They're independent. So the knowledge you need to use here from probability trees is that a pair of branches like this, for this outcome, the branches have to add up to 1. So if that's 0.42, this is going to be 1 minus 0.42, which is 0.58. And similarly, when we're talking about the transport, the probability that they took the train is 0.35. So train or walk have to add up to 1. So this one is going to be 1 minus 0.35, 0.65. And because those probabilities are going to be the same, regardless of whether it's a male or female, we can just write that down. So that's the complete tree. The person chosen at random receives a gift voucher. What is the probability that this person is female and travelled up the mountain by train? So the next bit of knowledge from probability trees is that when you're moving in the same direction from left to right across your probability tree, you will be multiplying the probabilities together and using the word and. If you find yourself using the word or, so if the question had said what's the probability of them catching the train, then you'd be saying, well, that's the chances of female and train going in that direction, Or, so you're going back to the start, mail and train. So that times that, or you then add the probability you get from that times that. But for this one, it's only one direction. Female and travelled by train would be 0.42 times 0.35. Female and train. And means multiply in probability language. So we got 0.42 times 0.35, 0.147. Similar shapes. So when you have shapes that are similar, it means that the only thing that's different about them is their size. The angles are identical. So if you've got similar shapes that aren't lined up, you would have to turn them to match their corresponding sides. In this one, that's done for you. You can see clearly that that angle's the same as that, that angle's the same as that. So they're in the same orientation. So the first thing you want to do is to work out what the scale factor is. How many times bigger is this to that on the corresponding side? What do you have to multiply 5.6 by to get 8.4? So to do that, the scale factor will be 8.4 times 5.6. No, sorry, divided by 5.6. 8.4 divided by 5.6, 3.2. So every side in the larger shape is 1.5 times the size in the smaller shape. So x is going to be 1.5 times 3.2. 4.8. So x is 4.8 centimeters. So when we're enlarging, we're multiplying by 1.5. Now to find y, it's smaller, it's a reduction on that side, so we're going to do the opposite of times it by 1.5, because that scale factor is the same for every corresponding side. So rather than multiplying by 1.5, I'm going to do the opposite. I'm going to divide 6.3 by the scale factor. .2. So that makes sense. Smaller shape, smaller size. 4.2. Explain clearly why the following statement cannot be true. The length of CD is 3.9 and the length of RS is 6.5. So CD is there. So if CD is 3.9, RS will be 1.5 times as big. So because CD times 1.5 times the scale factor is 3.9 times 1.5, which is 5.85. Not 6.5. So it's not 1.5 times bigger, i.e. RS is not 1.5 times bigger than 3.9. There are other ways you can explain that, and without seeing the mark scheme, I'm not sure exactly how many different ways there are of getting that, but basically what they're saying is show that the scale factor is different. So you could have done 6.5 divided by 3.9 and show that it's not 1.5. You could have done 6.5 divided by 1.5 and show it's not, etc., etc. So there's lots of different ways of doing that. Question 18. This was an interesting one. A rectangle of length 12 centimetres and width 2x minus y centimetres has an area of 72 centimetres squared. KLMN is a kite where KL is x and LM is y. The perimeter of the kite, so that's the distance all the way around the outside, is 33. Calculate the values of x and y. This is a simultaneous equations question. Let's work with the area of the rectangle first of all. So the area I'll get by doing length times width, which is 12 times 2x minus y, is equal to 72. Now then, you can be clever here and make the numbers easier, or you can just, I expect what most students would have done here is multiply out that bracket. So you do 12 times 2x to get 24x minus 12y equals 72. But if you spotted there that 12 is a factor of 72, that you can divide that in, rather than multiplying out that bracket, because there's a times there, I can divide by 12, and that will give me 2x minus y equals 12 sixes are 72, giving me that, which is going to be a much nicer number equation to solve simultaneously. You could have spotted there, maybe you could divide throughout, but that would be the clever thing to do. This is an overlap from the higher tier, and probably the higher tier kids would have done that. Intermediate tier would have persevered with that more challenging equation. For the kite, the kite's a symmetrical shape, so if that's 3x, so is that, and that is y. So 3x plus 3x is 6x plus 2y is equal to 33. So that's your second equation. Equation 1, equation 2. So now we're going to work with simultaneous equations to find x and y. And again, this is something that higher tier students would be better equipped to do than intermediate tier students. So in order to solve that, the easiest way at intermediate tier, you know that you have to do something to both to make those values, either the x values or the y values, the same. Well, because that's already a 2y, if I multiply that first equation throughout by 2, I'm going to get a 2y. And because one is negative and one is positive, if I add those two equations together, then the y's will go. So I'm going to multiply equation 1 by 2. And I have to multiply the whole equation by 2. So it's going to be 2 lots of 2x is 4x. 2 times y is 2y, and it's a negative, equals 2 lots of 6, which is 12. Equation 2 I'll just write down again. So if I add those together now, I get 4x and 6x is 10x. Negative 2 add 2, gone. 12 and 33 is 45. X on its own will be 45 over 10. X will be 4.5. So we want the values of x and y. I've worked out the value of x is 4.5. Now I need to find the value of y. So if I put that into equation 2, put that in that equation 2, I get 6. Just like with trial and improvement, I'm exploding the x plus 2y equals 33. 6 lots of 4.5, 27. Now, if you're coping with simultaneous equations, you're certainly going to be able to deal with the algebra of a linear equation here. I'm going to take 27 off both sides, leaving me 6. So 2y is 6, so y equals 3. So x is 4.5, y is 3. So there's 5 marks for that. It's quite a lot of work for 5 marks. And as I said, it's targeted more at the higher tier overlap than certainly a grade C student, and a grade B intermediate student will find that a challenge as well, because you have to form the equations. And the final question, right-angled triangles again. This time we're working with angles, so we know that we have trig to deal with. So in triangle ABC, AB is 6.5 and BC is 10.4. So let's separate out these angles, these triangles here, to make them a little bit easier to see what's going on. ABC, 6.5, 10.4, x. Angle BCE, so triangle CDE, so let me draw triangle CDE as well. Over here, CDE, I know that CE is 9.4, and I know that part of that angle is 22, but I don't know what the whole angle is. Calculate the value of x. Right. So the first thing is to calculate the value of x, and I've just seen the second part over there, hence find the length of DE. So part A, the value of x, I'm in this right angle triangle, I know 2 sides, so I should be able to find the angle. So let's go through the old triangles that I'm sure you will have learned. In here, opposite is opposite the angle I'm trying to find. Hypotenuse, remember, is pointed at by the right angle, and what's left is your adjacent. So I'm looking for the ratio that links opposite and adjacent, which is this one. So I'm using tan and I want to find the angle. So the angle is linked to sk or t. So tan of the angle is opposite over adjacent. Tan of x is opposite over adjacent. Now to find an angle, I've got to get inside that, so I've got to do the opposite, just like the opposite of squaring is square rooting, or the opposite of halving is doubling. The opposite of tanning is inverse tanning, which tends to be written tan to the minus 1 of 6.5 over 10.4. So if you revise your trig, that makes sense to you. If you've never done trig before, don't waste your time up here. Go and practice some more straightforward trig first. You need to make sure that your calculator has got a little D up there. If it's got a G or an R, you need to change that. I'll show you if I can remember how. I think it's Shift and Mode to get set up, and you choose 3 for deg. So that has to be in degrees. Okay, so we're going to type it exactly as we see it. Tan is the button, tan minus 1 is above it. Shift, tan tan minus 1, fraction button, 6.5 on top, 10.4 on the bottom, close the bracket. On the calculator, exactly as I've written, it's in degrees, 32.000, 32 degrees is good enough. If you wanted to put a 0.0 on, that would be fine. It's not asking you to give it to a degree of accuracy, so it's your call. Okay, so now that I know that that is 32, I know that that whole angle is 54. And I want to find, over here, DE. So name my sides now. This is opposite. It's opposite the angle we're dealing with. That's pointing at my hypotenuse, and what's left is my adjacent. So I'm looking for the ratio that links opposite and hypotenuse, which is sine. So this time I'm using that one. And I'm trying to find the opposite. So what's left is on the same level, which means we're multiplying. So the opposite is sine of my angle, 54, times the hypotenuse, which is 9.4. So on my calculator, DE is the opposite, that's what I'm trying to find, is sine of 54. So sine 54, it opens a bracket. It's really, really important at this point that you close that bracket to say that's the siney bit, and then we're multiplying that by 9.4. If you don't close it, then it's going to find the siney of all of that bit, not just of the 54, not just of the angle. That's equals 7.6 centimeters. I've gone to 1 decimal place because they're giving me my measurements to 1 decimal place. I've gone to no decimal places with the angle because the angles they're giving me are to 0 decimal places. So that's it. That is all of the second 40 marks of that paper. Hope it went well for you.